Hello, good morning. This is Rajesh and Yeg. Today we're going to present to you on Olap, Online Analytical Processing, which is the technology behind most of the business intelligence applications today.
Traditional data systems are tuned to many small, simple queries. Some new applications use fewer time-consuming analytical queries. New architectures like Microsoft SQL Server, IBM Cognos TM1, Oracle Olap 12c have been developed to handle analytical queries efficiently. Today, we will talk about Olap's history, its relationship to data warehouse, business intelligence. We will also talk about Olap cubes and different types of Olap. In 1962, Kenneth Iverson introduced the base foundation of Olap through his book, A Programming Language. In 1975, the first Olap product, Express, was launched. It was later acquired by Oracle. In 1993, Dr. Cord, who was known as the father of relational database, coined the term Olap in his white paper. He also established 12 rules for an Olap product. Since the late 1990s, companies like Oracle, Microsoft has launched their own Olap products. Now let's move on to data warehouse. Well, data warehouse is the most common form of data integration. It copies the data from various sources to a single database and keep it up to date. They are essential for analytical queries. We will understand why in the future slides.
Olap is a computer processing that enables a user to easily and selectively extract and view data from different points of view. It allows the user to analyze database information from multiple data warehouses at one time. This way, it helps in realizing business data to generate reports effectively. When we talk of business intelligence, we usually mean analysis and representation of data stored in an Olap cube. What is an Olap cube? It is a multidimensional data set built from a data warehouse. It utilizes a language of its own called MDX to query and load data. Let's discuss about the technical aspects of implementation of BI tools.
Large trade companies that have terabytes of data incoming from many sources all over the world. With such large quantities of data at their disposal, these companies want to analyze and track sales dynamics, see trends, and analyze the efficiency of their business decisions. It is vital to perform these operations in a timely manner. To do so, large amounts of worldwide sales data must be collected and prepared from one trade day so that analysts can work with the data the next morning. The key here is to prepare the data quickly. An industrial solution looks like this. Sales data from retail outlets around the world accumulates in OLTP databases, which are optimized for real-time transactions. The source could be virtually any type of database or a file containing data. All further stages serve one purpose: fast and interactive visual reports with the newest sales data for convenient analysis and decision-making. For example, a user examines a map or graph, clicks on an element, and receives valuable supplementary data. This cannot be done in real time if all queries are submitted into individual databases containing millions of records. For such purposes, there are technologies based on Olap cubes. They aggregate and store information in a specific way that allows users to ensure the interactivity of reports in real time. Let's examine how data initially stored in various sources is loaded into a cube. First, data must be arranged into a consistent formation and combined into a single repository. This is done by ETL processes, which are built for data conversion between OLTP, Olap cubes, and other sources. ETL processes comprise 3 steps. 1. Data extraction from the server's RAM. 2. Transformation and data cleanup. And 3. Data load into a shared storage, which is called data warehouse. Such a repository may contain large data arrays reaching more than 10 terabytes in volume. After the completion of data loadout for the current day in this storage, ETL process gives its ultimate command to the Olap cube to connect to the source to read and operate on raw data. As a result, the cubes contain the same data as warehouses, but aggregated and organized in a special multidimensional format that allows users to rapidly submit queried information into reports. This allows users to generate reports in real time. In these instances, data analysts use the query language MDX, which is the industry standard for accessing and querying data stored in Olap databases.
An Olap cube consists of 4 main operations: roll up, drill down, slice, and dice. These operations help in digging deeper into the data to get the required outcome. Starting with roll up. Roll up takes the current level of facts to reach another dimension. As you can see in the figure, we can perform roll up on the location axis. We notice that the aggregation of the data moves from a city level to a country level. Coming to drill down, this is an inverse of roll up, where you can see the quarters. Upon performing a drill down, we are able to fetch the data of each month under the quarter. Dicing and slicing. Dicing refers to a subcube. It defines a subcube by performing a selection of one or more dimensions. Slicing technique performs a selection on one dimension of the given cube, resulting in a subcube. It reduces the dimensionality of the cubes.
There are 3 types of Olap: relational Olap, multidimensional Olap, and hybrid Olap. Relational Olap, also known as Rolap, use relational database and SQL language to retrieve and calculate the transaction data to generate reports. Rolap uses a relational database. It requires more processing time and disk space to perform some of the tasks that multidimensional databases are designed for. MOLAP systems allows you to model data in multidimensional environment. MOLAP uses multidimensional array storage rather than a relational database. It provides faster query performance due to optimized storage along with multidimensional indexing. Hybrid Olap is a mixture of MOLAP and Rolap technologies. Olap leverages cube technology for faster performance. When needed, it can drill through from the cube into underlying relational database. Cubes stored as Olap are smaller than equivalent MOLAP cubes and respond quicker than Rolap cubes. Olap is generally suitable for cubes that require rapid query response on a large amount of data.
Olap today is being utilized in almost all business intelligence reporting tools. Microsoft Excel in itself is a ready-to-go Olap tool. It provides a number of advantages. Olap creates a single platform for all information and business needs, thereby helping in analysis. It allows a manager to pull down data from an Olap database in broad or specific terms. Although being quite helpful and advantageous, it does have its drawbacks. Olap has a great dependence on IT, as it requires a large number of code or scripts to push and pull data. It also has a difficulty in managing the dimensions for complex data. As the data becomes more complex, it gets difficult to create dimensions in an Olap cube to store the data. Thank you so much for listening.